Now we're going to look at a couple of combinatorial theorems that are named after very famous mathematicians. Blaise Pascal. Pascal's rule says that if 1 is less than or equal to r, which is less than or equal to n, then this equation holds. N choose r plus n choose r minus 1 is equal to n plus 1 choose r. Notice that r has to be bigger than or equal to 1, then normally we have just greater than or equal to 0. But in this case, we have an n choose r minus 1. So if r were equal to 0, clearly we'd have an n choose negative 1, which makes no sense. All the numbers have to be non-negative. Okay, this one I'm not going to prove. I'll leave that one for you to do in the homework. Basically, you'll just write this down using the definition, factorials, n factorial over n minus r factorial, plus, and do the same with this, massage them a little bit using algebra, arithmetic, until you end up with this on the right-hand side. So, Sir Isaac Newton's identity says that if 0 is less than or equal to r, which is less than or equal to k, which is less than or equal to n, then this equation holds. N choose k times k choose r is equal to n choose r times n minus r choose k minus r. So for this one, notice that everything makes sense. The bottom number cannot be bigger than the top number in a combinatorial, when you're doing n choose k. Notice k is not greater than n. Notice that r is not greater than k, and so on. So it makes sense. Well, let's prove this. So I'm going to start with the left-hand side, use the definition, massage it a little bit until I get something that looks like the right-hand side. So I started the proof. I said, notice that, because that's going to be the only 2 words in the entire proof. The rest of it is just arithmetic, essentially algebra, and definitions. So we will notice that n choose k times k choose r, by definition, is equal to n factorial over n minus k factorial k factorial. That's the first one. And then by definition, the second one is k factorial over k minus r factorial r factorial. So I'm going to do a little bit of rearranging here. I want to have n factorial over r factorial for one thing. So I'm going to move the r factorial over here. I'm also going to notice that those two just go away. K factorial over k factorial. That just cancels each other out. And let me see, maybe I can save a line. I'm going to do one more step. I'm going to multiply this by 1 in the form of n minus r factorial over n minus r factorial. Perfectly legal to do. And now let's see if we can get this arranged in a nice way. I want the n factorial over the r factorial, and I'm going to take this n factorial, n minus r factorial right here. Let me make it blue again so we know where it came from. Okay, so I've taken care of this term, and I've used that term. So on the next fraction, we're going to have the n minus r factorial on top. Now I've taken care of both of those, but I still have this n minus k factorial to deal with, and I have that k minus r factorial also. So k minus r factorial, that didn't move. But I still have this n minus k factorial. I think that's the only thing I have not dealt with. I'm just going to make a note that n minus k factorial is equal to n minus r plus r minus k factorial. This is just a side note. I'm going to write n minus k factorial like this. N minus r plus r minus k factorial. So now this is completely equal to this. I want you to double check that. It's easy to find the n minus r factorial over the n minus r factorial. The k factorial over k factorial went away. Here's the n minus n factorial over r factorial. And here's the k minus r factorial. It didn't move. And then I moved the n minus k factorial to right here, but I wrote it as n minus r plus r minus k factorial. So I'm going to do one simple modification on the next line. N factorial over r factorial, n minus r factorial, times n minus r factorial over k minus r factorial. We'll notice that this can be written n minus r in parentheses minus k minus r in parentheses. So the only thing I did was change this. Notice it's n minus r minus k plus r. But if I put the if I put them in parentheses, I have to change the sign. So this is minus k plus r, just exactly like that. I think we're done. This is simply n choose r by the definition. And now this one's a little tougher, but actually look at it from this standpoint. It'd be n minus r factorial on top. And on the bottom, you should have an n minus r minus k minus r in parentheses factorial times k minus r factorial. So that's exactly what we have. A couple little tricks in there, but basically a lot of algebra. And we just proved Newton's identity.